Thank you very much for this nice introduction, and I want to thank you also to invite me to this institute. It's an honor and a great pleasure to be here and to meet so many outstanding scientists. As one of my main qualities as a journalist is to be curious, of course, and I have the opportunity to satisfy this curiosity here in many fields of science, and that's great for me, because usually you have very little time as a journalist to find out about things, because you have to write an article and perhaps you get $300 for it, and you cannot spend a week on this. So it's great to be here and to have this time at once. I also want to thank you all for your willingness to come here and to listen to what a journalist has to say, because journalists normally are not very much respected. Perhaps you have experienced what happened quite a lot of time to me when I introduced myself as a physicist. People say, "Wow, you are a physicist." And they are scared about this, and they hover between incomprehension and admiration, because it's such a difficult subject, do they believe. It's funny that people are so much afraid of science, because people are interested in science and scientific and technical things. They like new cars, they like the iPhone, they are queuing for the iPod, you know, and they like these small cameras. And many people have a computer or use the internet, and they don't realize that behind all this there is physics. Most of them will use what we call the Beckenbauer principle. You know, Beckenbauer is a quite famous soccer player in Germany, and he used to say, it is not necessary to know how something works, only that it works. And I think many, even well-educated people think like that. You can find the strangeness with scientific things everywhere. I remember very well our German Chancellor Helmut Kohl, who never hesitated to say, to confirm that he hated math and physics already during school time. And the same is true for many celebrities, politicians and intellectuals, I think. It's always a well-accepted joke that you can crack on every party. But that's not only a German problem, I think. Bruce Levenstein, professor of science communication at Cornell University, described the same thing in the United States. He said, studies conducted in the developed world, especially in the United States, show the general public generally perceives science as a beneficial force in human affairs. At the same time, those surveys show that public knowledge of the details of scientific knowledge is extremely low. And also in Russia, they have this problem. The Russian scientist and TV host Sergei Kapitsa, the son of the Nobel Prize winner Pyotr Kapitsa, wrote 10 years ago, "The lack of a human and cultural message of science has definitely contributed to the estrangement and even the divorce of science from society, which can be seen in many instances." So, you see, it's a very ambivalent feeling that people have towards science. Because on the other hand, they have great expectations and high hopes. They hope, for example, that solar energy can solve the energy problems. When a disease comes up, they want rapidly a new vaccination against it, which shall protect people. New cars should need less fuel and become safer and safer, and they should be non-polluting. Or we in Europe got a new money 10 years ago, the euro, and when this happened, people expected scientists to make the money. Forgery proof, of course, because that's a thing science could do. Even in the commercials you find this hope. For example, Hewlett-Packard has a commercial which says, everything is possible. Or there's a German TV spot of Toyota, nichts ist unmöglich. That means nothing is impossible. Now you see, it's as I said, it's ambivalent, and we science writers are the interpreters between science and the public, and that's quite a difficult task. It's an exhausting job because you have to learn many new things every day, and you never can sit back and say, "Oh, my education is finished now. I can deal with these things, and I need not learn anything more." But nevertheless, for me, it's my favorite job, and I do it for 30 years now, and I still would do it again. I like it very much. Before I want to talk about the difficulties of my profession, I want to tell you a little bit about myself. I began to work as a public relations officer in the Max Planck Institute for Plasma Physics in Garching, and there I became acquainted with the scientific with the problems that scientists have to talk about their work and describing their problems, their aims and their methods to the public. And they also have difficulties to tell people why public funding is necessary for good research. And I learned there to tell pupils and teachers and laymen about science, and to tell them also how difficult it is to make progress and how slow it goes on. After a few years I changed and to public magazine. This is the magazine Quick, which doesn't exist any longer, and it's a magazine which mainly wrote about entertainment, sports, politics, and a little bit about science too. And there I learned which problems journalists have to get reliable and understandable information from the scientists, and how difficult it is to find news from the scientific world, and especially news which are interesting for the normal reader. And there was another problem because most of the readers were interested in, as I said, entertainment, sports, and politics, and you had to get some space in the magazine for science also. That was difficult to find out sometimes, and I learned quite a lot there. After this, I went to this popular science magazine, and then no longer it was difficult to get space because the whole magazine was dedicated to popular science, and that was quite an interesting time because you could write long stories and go into detail in many stories. I liked this very much, and after this, I decided to become a freelance science writer, and I do this since nearly 20 years now, and I write for newspapers and magazines, and I write books, popular books, for example about brain research or quantum physics or the moon, or a biography about Marie and Pierre Curie. And I also wrote a book which is not scientific about how you make the best of your time and how to live slowly. Now you understand that I know quite a lot about this job, and I want to tell you a bit about the difficulties we have. The main thing in journalism is that you have to sell the newspapers. You have to sell the newspapers, the magazines, the books. And why should people buy something which they are not interested in? So you always have to make things so interesting for the readers that they say, yes, I give my money for something which I want to know. And that's the main point everywhere. And the chief editors are responsible for this. And a chief editor who doesn't sell enough copies, he will lose his job very fast. So we science writers have the difficulty to make science as interesting as possible to normal people. And especially the freelancers, because perhaps I found a topic which I think is interesting, and then I will tell an editor in a magazine or a newspaper, oh, there's something interesting, and he will go to his head of department then and says, oh, there's something interesting, couldn't we write about this? And the head of department perhaps goes to the chief editor or tells him in the big conference, somebody has said there's something interesting and perhaps we could write about this. And the chief editors normally, well, the science writers mostly are very well educated scientifically, but the chief editor never is, so he nearly never is. He will say, oh, what's that? Is that really interesting? Should we write about that? I don't think so. So let me give you an example. When LHC began its work 1 or 2 years ago, it broke down, as you know, very fast. But everybody has written about that already. 1 year later, it came back. And then the editors said, yes, we have to write about this. LHC is beginning its work again. But the chief editors said, well, we have printed that already, it's no longer interesting. Isn't there anything new? But you couldn't say anything new at the beginning of the work, of course. So people are thinking, what might be new? And there evolved the idea that they are producing black holes, little ones. And then the editors perhaps said to their chief editors, oh, perhaps they might produce black holes, and that might be dangerous. They could swallow perhaps the CERN or even the Lake of Geneva, you never know. And the chief editor said, yes, that's interesting, let's write about this. So that's how a topic comes up, and I remember that one week ago, I think, there was a big press release from the security office at the CERN, which was sent to all German politics, which told that the black holes there are not dangerous. So in other fields, it's not so difficult to bring things to a newspaper. For example, in politics, well, every day happens something new, and a newspaper will write the new things, so that's not difficult. There are killed some soldiers, or politics has said something, or there was a conference, I don't know. And in sports, you have the games, the results from the last weekend, and you have to bring these and make some comments and so on. So nobody will argue about writing about these things. Or in entertainment, somebody is divorced or was cheated, or I don't know, and you write about these things, always the news. But what are news in science? Perhaps for you, news in science are when something is written in Nature or Science. Or if you have a conference and you heard something new is announced there. But is this really interesting for the public? For the public, there might be interesting, perhaps a new discovery. So the exoplanet people here are on the very good side, because to look for life in space, that's always interesting. And if they find a new planet, exoplanet, that's quite interesting too, but not when you have found already 400. So the next one, the next one is not so interesting. A new discovery might be interesting, but most of the time it's accidents which are the news. So Chernobyl will explode, or the nuclear power plant of an underground of a submarine will explode, or an earthquake or tsunami, or like happened a few weeks ago in Germany, half of a village will slide down into a lake where they did mining before, and then you are called as a science writer and say, oh, find out how could it happen, and how could you prevent this, and how could people make something to find it out before it happens, and things like that. But that's always accidents, or if the space shuttle will explode, or things like that. So that's not what we really like. So it's very difficult to find out new things which we can bring in a newspaper, and that's and I would like to think. I would like you to bring you to think about this topic, because sometimes you find out very interesting things and nobody knows about it, and that might be only a very small thing, and just think about whether it might be interesting for a journalist too. Another point is that the freelance science writers don't make the headlines. Of course they make headlines, they write headlines, but those will not always be used. They give the article to the newspaper, and then the editor will choose a headline, and it must be as sensational as possible, of course. And it's a really art to make headlines which are right and sensational, but it doesn't always come like that. I got two examples. There was written the headline "Life Discovered on Mars" in a German newspaper, but there were only some structures that might be the remnants of some bacteria, perhaps. But just as I told you before, every person tells the next one, and at last the chief editor says, "Oh yes, life on Mars, that's okay." Or another headline was Schering. Schering is a German pharmaceutical company. Schering makes men infertile. And actually, the company developed a birth control pill for men. When you talk to journalists, you have to know one thing. There's a great difference between news in a newspaper and stories in a magazine. The news in the newspapers are mostly this size, and the most important things have to stand in the beginning, in the first 4 lines. So, for example, Professor XY from MIT has discovered a totally new family of high-temperature superconductors. And then the facts are presented a bit more detailed, and then there is all the information that is not crucial, such as the co-workers, the history of the discovery, how much it costs, and so on. And when the editor gets the article and puts it on the page, the newspaper page, sometimes it's too long, and then he will only cut from the end. So that's why it's made like that, because the not so important things are at the end, and you can cut them without losing the most important things, which are at the beginning. So when you talk to a journalist from a newspaper, or he asks you about things, keep this in mind. Just tell him the most important things and not the whole long story, because first of all he doesn't have enough time to listen to you, and on the other things he will forget half of it. And the third thing is he just has 100 lines perhaps, or 120. The other thing is when a magazine brings a story, most of the time they have several pages for it, and there it would be bad to tell the most interesting things in the first few lines, because everybody would stop reading and would think, why should I read the rest of it? That's why journalists always try to begin such a feature with something unexpected, unusual, or intriguing. The reader must be caught in order to go ahead with reading. The facts are only later explained. So when you meet a person who will write an article about for a magazine, a big article, you can tell him everything. Just tell him about the history of the discovery, and tell him how you found this out, and tell him a bit about your person. And he will talk about persons very eagerly, because every story has to have a protagonist, and not to say a hero. It's much more interesting to read a story about a person who does something, and I will come to this later again. So. Long stories also have to have a dramatic composition. They have to build up suspense, and they are written totally different than newspaper articles. So don't be astonished if the article from a magazine journalist will be not what you expected. Every journalist is committed to check the facts. That's our profession. We have to do this, or we should do this. And if you are not, if we cannot estimate the plausibility by ourselves, we try to find some expert who can do it, and we ask other scientists who work on the same subject. And so don't be angry and don't be astonished if you find in an article opposing statements from other scientists, or don't be astonished if you find the article in the article statements from other scientists about your work, because that's our business. We have to check out. For example, think about global warming. Many scientists say it's global warming, but others say perhaps they just make it so dramatic because they want more money for their research. Or think about the predictions of earthquakes. It's very difficult also. Or the prospects of fusion energy. Some think it will come in 10 or 20 years, and others think it's nonsense and will never come. So you always have to find out as a journalist what is the opinion of the community, and you have to state many different opinions to show this. So that was about the difficulties we science writers have in our work. And now I want to tell you a little bit about how you could make us life easier. Normally you write articles for scientific papers, you write scientific papers, and that are quite different from what we want. So don't try to, if you write for a magazine or if you talk to a journalist, don't try to do the same thing as in a scientific paper. Don't orientate your style at these papers. Just try to talk to the journalist as if you would explain your work to a good friend, or perhaps to your wife, or perhaps to your cleaning lady, or to your dog, or whatever. And try to explain things. Because you must think that we journalists always have to write about different things. Just take me as an example. In the last few weeks I had to write about metabolomics, for example, a big story for a magazine. Metabolomics is the field where they try to find out how the metabolics of our body works, which is not really well known. They make high precision analysis of the chemicals in the blood and the urine, and they use stable isotopes for tracing something in the body and so on. That's very interesting, and it could explain perhaps why some people get fat and others don't, or why some people get ill and others don't. Or I wrote a story about battery management for electric cars. Or I wrote a story about X-ray lasers. They have invented an X-ray laser in Munich, which is quite small. It's only 5 meters long. Usually you need a field like a soccer field to build up an X-ray laser. And they want to make a very strong X-ray laser there on this small size. So you see, the topics are very different, and you never, as a journalist, you never can know about all these things by heart. So you need scientists who will explain to you in an easy manner, and to be patient and to tell you. And that's why I want to ask you, please explain. And also be personal. Don't say as in scientific papers, we, if you mean I. Don't use passive sentences. Don't say things have to be done, but instead I want to do the following. Every interesting story has to have a hero. So it's you. And you also cannot hide behind these sentences, these passive sentences. And please use simple language, of course, you know this, not scientific terminology. If a technical term is inevitable, just explain what you mean. For example, an exoplanet is a planet which is outside of the solar system. Sometimes it's quite easy to explain. Sometimes it's not. A very interesting thing for journalists is to ask, what is your work good for? And and that is also interesting for you, because you have the opportunity to think about your own position. That might be quite interesting for somebody who's always working. And especially for fundamental research, sometimes it's quite difficult. It's easy for exoplanet researchers because everybody understands this. Another thing I want to ask you is, pick up the listener where he is. there is a layman and there is an expert, and between these two, there are so many different places where people can stand. They know a bit about it. They have a hobby. They like this subject, and they have heard a bit about it, or they didn't hear anything about it before. So just ask them how much they know already, or what their education is. But don't do like a German politics used to do. He always asked journalists, do you at least have an A-level degree? You could better ask, did you ever hear of exoplanets? Or do you know which are our neighboring planets? Or did you know that there are many suns in the universe? Or are you interested in astronomy? So you can find out slowly how much the other one knows, and you can explain on his level, and that's very important. I just find a few things about the last point. What is your work good for? Sometimes it's quite unexpected. For example, the explanation of biofilms. There was a biological program here a few weeks ago, and they, for example, Michael Brenner, who was here also, he's working on biofilms that are these societies of microorganisms like bacteria or fungi, and you can find them in a sink or in water pipes, and this slimy sort of thing. And they are very interesting because they work together, these little animals or fungi or bacteria. Some of them get food, and some of them make the communication, and some of them make the clinging to the surface. And it's very interesting to find out how this works and why they do it. But that's only fundamental research. But you could use this for a very interesting purpose. In hospitals, these, I think you call it indwelling device, like infusions or catheters. They make biofilms. There will be biofilms soon at the surface between fluid and solid. And there can happen infections, very bad infections, when toxic bacteria come to this biofilms, and they have enough to eat there. And so it's a very interesting purpose, and hospitals would be very glad if you would know how biofilms really work, because then you could prevent them. Or another example was the ISS. They make experiments there with people who live there longer. How does their muscles and bones degenerate? And that could be interesting also for ill people, because when they have to lie in bed for a longer time, what could you do to prevent their muscles and their bones get weaker and weaker? So sometimes it's quite interesting to think what things are done for. When you talk to somebody and you have found out what level he is, then talk and talk, but sometimes check back. And you just could ask, did you understand what I told you? Or you put a question about what you have told him. I had a very bad experience in this thing. When I was in the Max Planck Institute for Plasma Physics, I told you I had to show pupils around. And normally I gave a talk at the beginning, told them about plasma physics, fusion energy and things like that. And then I showed them around for an hour and showed them the experiments, the plasma experiments. And then we came back to the conference room, and we had the opportunity to ask questions. And that took, let's say, 1.5 hours, the whole thing. And once there was a group of pupils, and we came back to the conference room, and I always had talked about plasma and plasma experiments and so on. And we sat there, and then one pupil showed up and said, excuse me, what is a plasma? And I realized in this moment that it was too common for me. I didn't explain what a plasma is at the beginning. So I should have checked back, and I would have found this earlier, not only at the end. That would be better. Last week we had a discussion at the table outside, and some scientists asked, when should we make a press release? And I said, don't make press releases only at the beginning of a project. It's not very interesting. You just can write, they are beginning a new project, and there will be money, let's say 4 million for this project. They want to find out this and that, and it will end in 5 years. So that's not a news. Nobody wants to know about this, except you, of course. It would be better to write a press release at the end of a project, because I would like to know what has come out of this project, what were the results. And so it would be better to make a press release or tell people about projects in the middle or at the end of the projects, and talk about what has come out. You must always think that we journalists are not fundraisers. Sometimes there are scientists who refuse to talk to journalists at all. I can understand this, and you're free to do it. But when their project is running out of money, they suddenly think about ways how to tell the public how important things are that they are exploring. But my colleagues and I, we notice this, and we don't want to be the willing tool for upcoming negotiations with the politicians. So just tell us all the time. Sometimes it would be interesting for us to get to know about things which didn't work also, because that might be an interesting result also. And now I want to give you a last point, which I think is very important. A few years ago, a few decades ago, people always thought it would be enough to tell the public the facts, just to produce a better understanding of science. But that didn't work. And meanwhile, we know, formerly you thought that the more people know, the more they would understand the way how scientists think and work and make their decisions. It doesn't work. As I already mentioned, there's a deep mistrust of science in the public, and many people don't think that scientists work to find out the truth, but at least also to earn as much money as they can. Just think of nuclear energy, genetic engineering, or environmental pollution. People are very anxious about these things. So, to convince people, you don't have only to show the facts, but try also to give them your own fascination, your passion. Tell them why you do this. There's also interesting to give the emotions to the people, not only the facts. And sometimes emotions are even more important than the facts. This is especially true for fundamental research, where you cannot find a practical use. So that's where I want to finish now. There would be quite a lot of things, practical things, to tell you how to do, how to explain, how to give an interview, or how to write a press release, or things like that. But I think that would be better to practice it by yourself, and I would be glad to meet you on Fridays to make some workshops about these subjects. So, thank you for your interest.
Well, thanks, Brigitte. Are there any questions? Let me ask you a question. How do you can you compare the way German magazines, the press cover the science compared to the United States?
For many years we thought the United States are the paradise for science writers, because they have some more magazines and they are were much opener to scientific things and to popular scientific explanations. But meanwhile, it became better in Germany too. And most of the big newspapers have 1 page at least per day on science. That's good. You have not to fight for the space every day, so you have 1 page. And that's perhaps since 5 years. But when money is scarce, the politics is most important, sports is most important, entertainment is important, and also the feuilleton. And science is the first thing to become shorter, and so it might be more difficult when the advertising goes down and the newspapers don't have enough money.
Well, how do you go about yourself finding out what's interesting to write about? I mean, what is your mechanism? Let's say when you're not doing something like visiting KITP, but just when you're, working at your magazine.
How do I find out news?
Science?
No. The most interesting thing is if a scientist tells me, because it's exclusive for me.
So scientists come to you?
Yes, often scientists or public relations officers tell me, I'm 30 years in this business, so I know quite a few people, and they tell me, and I can write the story before others know about it. That's the most interesting thing. But of course, I get lots of press releases every day, 20 or so, and there you can find quite a lot of interesting things. And I also look into scientific magazines, and go to conferences sometimes if I have enough time.
What is the relationship between journalists in the capacity you are for these 2 months and the scientist working here, in the sense of, if I get called by a journalist or see a journalist and have a conversation in a scientific meeting, I assume everything is on the record. There can be some things that are said to be off the record, but they're only sort of off the record. But if you're here in residence while we're working, what are the professional codes of ethics?
What you say?
I'll record it anyway.
I always try to find out also the secrets, of course. But usually, if you talk to a journalist and you tell him things about, let's say, about other scientists who compete with your competitors, and they are eager to hear this, of course. But if you tell them about them, you also could say, you are not allowed to use this for your article, and every journalist will do it because he does it only once if he doesn't obey, and you won't tell him anything anymore. So either you don't tell him what you don't want to have written, or you tell him, please don't use this. Politics do this all the time. They are talking about everything, and they say it's only between you and me.
So
How do you deal with the kind of tension between kind of writing stories about individuals and the fact that science is often done in collaborations? So it's something like the LHC, where you have these experiments with thousands of people. But at some point, if you want to write a story, you're going to need to focus on individual people, even though many people have contributed to the science, and it doesn't just belong to.
Yes, that's quite difficult. But in this case, you could talk about how this work is done, about the conference they make, the struggling for the right thing, about how they sit nights and nights to talk to each other, and the cantina at CERN is very interesting when you go there at 3 o'clock in the night and they're eating ice cream there. You have to talk about how it works and to emerge in the life of the scientists, and then you can bring some interesting facts also. It's very difficult to take a single person out of it, and so you can't do this in such a case, I think. It will be a difficulty with the Nobel Prize also, if they find something.
I'm sure this question has been asked many times, but you mentioned earlier that you were, when you write a story, you want to get a sense of what the community thinks. Mm-hmm. But obviously there are many forces that push you towards sort of giving the dissenting minority, or even if it's a very small minority, a relatively bigger part of your story than the 95% of the people that are working towards building a consensus. Because the more interesting story would be, okay, well, these people are disagreeing about this thing, that's a more interesting story. And also, if you want to have a bunch of opinions, if all the opinions sound the same, your story doesn't look very good either. So you make sure you get people that don't agree with what's going on. Yes. So this always then leads to this issue, okay, well, it's a 50-50 proposition whether global warming is true or not. If you read any paper, any article that's written about it, or a 50-50 proposition if evolution is true or not, because there's so at least if you ask the people in the United States how many of them believe evolution versus creation.
But you have to ask experts, of course.
But in any case, so the question is, do you view it as your task to write an interesting story, or to have a way of communicating what scientific consensus really means?
Yes, it's always interesting to say Einstein was not right. So, and as you have, I talked to some of the exoplanet people, and everybody said, I have quite a big file from people who say something which doesn't work, and they have sawn aliens and they don't believe us, or things like that. And they are, what did they call it? Crackheads. It's the same with me. They call them crackhead. It's the same with me. There are often people who say, I made a discovery and it's quite different from all the other things, and military people want to keep it
so you're getting those requests, and then you have to...
And you just have to find out which are reliable experts and talk to these. And it's very difficult sometimes to find out, because not all experts are as reliable as each other. But well, sometimes you do wrong, of course.
But do you feel that you're part of this tension, or that you play an active role in it, or you're just reporting on it? Because I think in some ways journalists do play an active role in educating the public on what science knowledge is.
Yes. Not about what science knowledge is, but what is important. For example, think of the pollution thing. Sometimes perhaps it might be interesting for a journalist to bring a thing up that scientists don't like to hear. Perhaps we should do that. And if scientists can prove that it's wrong, they will do it. And they can say, you have been wrong. But of course, we don't always report about the mainstream. It would be boring, as you said. That's why all these stories about global warming are so boring. I think some more questions.
Right, so I'm wondering whether you could say a little bit more about the perception from the journalistic world of this topic like global warming or these black holes at LHC that you mentioned, because this has led to some frustration in the scientific community to some extent, and one could be of the opinion that maybe that's a case where, well, depending on how you want to look at it, it's complicated, but this is a case where being less involved with journalists might be somewhat better, or, the argument could be made at this. So I'm just curious, what's the perception from your world of this developments about global warming, this whole thing about the black hole being dangerous? Because, I think many people in the room have some notion of what the scientific community thinks about this, but it's difficult to know what the journalists think about it. It's related to the question before, I think. So if you could tell us.
Mistakes always happen, of course, and I cannot put on my shoulders all the mistakes of all journalists now.
It's not about blame, it's just curiosity.
No, I understand what you mean. You must also think about the difficult role a journalist has. Normally, science writers are scientifically educated people, and they are quite good at their subject. But there are many journalists, especially in the newspapers, in the smaller newspapers, who have to work about everything. They must write about politics and about economics and about some local things. And for example, every year there is in Lindau at the Lake of Constance, there is a conference of the Nobel Prize winners, And perhaps you have been there once. Every day there's a press conference, and the Nobel Prize winners tell the journalists what they are doing and what they were talking about. Now this poor colleague from the Lindau Tagblatt, which is a very small newspaper, he has to write what I told you, he has to write about everything, and then he comes in and hears about bodies and about exoplanets and about strings and whatever. Could you imagine how difficult it is to write about this? So he cannot judge what is right or wrong, just tries. And the same it is with the black holes and LHC. People have written this, and other editors have thought it's interesting, and we should write. It's a competition between the newspapers also. And if something is interesting, others write it too. It's very difficult to stop such a thing. We science writers always try to find out what happens before, but it's difficult to stop, and you just have to think it will go away after a few weeks. Nobody will talk about it any longer. So
that was the best thing that ever happened for the LHC.
Yeah.
In fact, it might have been their PR department.
Just to be upbeat from it, I'd agree with what you're saying there. In some sense, the cliche, there's no such thing as bad publicity. But if ultimately things are resolved, as you say, people know about the LHC now. They've heard of it. And I think I would actually observe both in Europe and in North America that it seems to me over several years I've been a scientist that the actual coverage of science has improved enormously, both in Europe and in America. I would say the actual media coverage is actually rather good of what we do in a certain way, and I think people do.
The LHC is an example, but then global warming is another example, where some of the reporting on the recent scandals or whatever are a little superficial, and there has been very little in the science reporting. So now there has been some about the problems, but never about I've never seen in a science setting journalist who goes and questions the background, the financial support, the motives of their critics, which are of the critics of global warming, which are infinitely more corrupt. And that is never reported. So sometimes reported there are these critics or these institutes which are supported by other companies. And no investigative reporting has been done on those economic interests, which are very powerfully fighting regulation. Whereas when it was discovered, these secret emails where scientists actually went to each other and said, how can we discredit our opponents? everybody was shocked. The whole thing, so it was a little unbalanced. It was sort of lack, and that's very, very different from black hole.
Harder to discredit the global warming skeptics than to discredit scientists.
I have a question. I saw a program pretty detailed about ITER with the fusion laboratory, and is that you haven't seen much about that? Is there reasons for that, or maybe I'm missing something?
About what? ITER.
ITER.
Oh yeah.
Fusion.
I think that's because they stopped building it just at the
Oh, I see.
moment.
So they
I tried to find out, but they have a big.
it looks enormous. I mean, it's fun.
Yes, it looks enormous for the future.
Competitive with the LIC.
Yes, but if you look at the site at Cadarache, you can find pictures in the internet. They just have made a plane and they have an arrow and say, here we will build this plane.
Where is it actually?
In the south of France. And they have, it seems to me they stopped it, and they don't tell you. I asked them, oh, it will come soon, but I don't know what happened.
The whole project is decades long.
Yes, I know. But at the moment you want to get the progress, and they decide to build the buildings now, and they don't do it. I don't know why. Perhaps they have a shortage of money. I don't know.
The price tag is huge, right? Comparable to the LHC or something? Tens of millions of dollars?
I don't know it by heart. It's billions in any case.
Okay, I think there's more to discuss in future meetings, and thank you.